So I hope that you are here because you would like to know about whether you should rewrite in Rust. As my own room monitor, I'm going to double check with our AV folks. Am I recording? Maybe? I see a yes gesture. Hooray, so we are probably live not only to the people here in the room, but to everyone on the live stream and to posterity later on. So before we get going, I'd just like to know a bit more about who's here in the room. Who here, by a show of hands, thinks that you know the answer that I'm here to tell you for this question, should you rewrite in Rust? Yeah? Hardly anyone. You don't make any assumptions. That's great. So who here thinks that I will tell you, yes, rewrite your code in Rust? By a show of hands. Surprisingly few, maybe a dozen. And who here thinks I will tell you, no, don't rewrite your code? About the same. Well, congratulations, you're right. So I am Emily Dunham. I'm from the middle of nowhere in Oregon, and I work as the DevOps engineer for Mozilla Research, which means that I wear quite a few hats at the same time. I work a bit on Rust's infrastructure, quite a bit on Servo's infrastructure, and now on the virtual reality team's infrastructure that's part of research as well. So while I'm involved with and engaged with the Rust community, I'm a member of the Rust community team, I do a bit of Rust programming, but I'm more of a compiler groupie than a compiler hacker. But that's okay, because I know a bunch of very smart people, and I have combined my own experiences and asking them a whole lot of hard questions about what do you ask when someone says they want to rewrite? How can you tell when you should rewrite something to come to the conclusions that I'm going to share with you in this talk? So I'm going to talk about whether you should rewrite your code at all, whether you should rewrite in Rust, and how to do that if it turns out to be the right thing for you. So, should you rewrite? Should is a value judgment, and all value judgments are based on certain assumptions. The assumptions that I'm going to make here for us to even be remotely on the same page are that I'm assuming that you're working on some code. I'm assuming that you're working with some other people on that project. Probably some of them help you with the code, some of them help you with non-code aspects of that project, but you're not just going it alone. And you probably have someone who uses that code that you're writing who isn't just yourself. So the other basic assumption that I'm going to have to make in order to call things good or bad is that people's time and happiness are ultimately what you're optimizing for. You're going to basically try to do the things that make your code, save people's time, and make the people happy. So those people is not only yours, it's also the colleagues that you're working with, both technical and non-technical, and the people who use your product. So anytime we're going to call something good or bad, it's striking a balance between what it does for all of these different groups. So now that I've got that out of the way, let's talk about rewriting code. Rewriting has a bunch of different definitions. Some people are like, rewriting is when you don't look at the old source. But no, I'm just going to say that rewriting is when you had some code that tried to solve the problem, but you're going to say, no, I'm not going to use that code. I'm going to start new and do something different for that portion of the code. I'll also talk about refactoring, differentiated from rewriting as trying to modify what you already had in order to get to where you want to be. So you can categorize rewrites by how big they are. How much of your code base are you tossing out and starting over on? A smaller rewrite, like I'm just going to rewrite the body of this function for some reason, is highly constrained, but it gives you less opportunity to introduce new bugs, and it can get done quite a lot faster. Whereas the extremely large rewrite that some people online will often suggest in a debatably satirical manner, just get rid of it, just rewrite the whole thing in Rust, can be enormous, has a much more greenfield, start anew, fewer constraints implication to it, but you also get to reintroduce every bug that the old code intrinsically encoded a solution for. And the larger a rewrite is, pretty obviously, the more time it's going to be taking that you could have spent doing anything else on your project. So You can also categorize desires to rewrite code by what someone hopes to get out of it. So the main motivations to try to tackle a project again, tackle a problem again from scratch that I've identified are, first, you want to learn the tool that you're tackling it in. You're like, I want to learn this new language, so I'm going to write FizzBuzz in that language so I know how it works. Then there's the motive of understanding a task. There's, wow, managing this memory is really hard. Maybe I should try writing a similar piece of code in a language that helps me with memory to see how it works when it's working correctly. And finally, the one that you only really hear about in popular conversations about rewriting is rewriting because you want to ship different production code to your users than you're shipping right now. So a rewrite, in order to understand either the tool or the task, is going to be somewhat costly. You're going to spend a bunch of time researching how to do it, writing that code, and debugging the code until it works in the way that you expected. But rewriting with the motive of deploying that rewritten code is immensely more expensive. More people have to do research, coding, and debugging, and you have the communication overhead of explaining it to everyone else who interacts with that code. You have an obligation of backwards compatibility if you're writing a thing that you claim will fit in and replace something that's kind of sort of working already. And you have whatever tooling was previously deploying the code is probably going to need some minor or major changes for the rewritten code to work with it. Plus, you get the opportunity to introduce a lot of new bugs, and you're going to have to fix them. And again, everyone involved, not just you, but your colleagues, both technical and non-technical, and the users of the product are going to have to learn about the new system. That's starting to sound like we should never rewrite anything. So why does anyone? Because in addition to those major drawbacks, you can get some huge benefits. You can get improved performance, especially if you had previously been using a language or tool where performance is not really its first priority. Or if you're using tooling where performance is the first priority, you can get radically improved maintainability by switching to a tool that prioritizes the ease of reading and writing the code in it. And sometimes you just need to increase your contributor base. It can be really hard to find people who know and want to use some languages or some tools. So in some circumstances, switching can actually get you those people that you needed to keep the project alive at all. So when you're thinking, oh yeah, okay, it looks like I might want to rewrite this, start by thinking about how you'll communicate about it. This is true not just of rewrites, but of any major code change. And the first step to communicating what the problem is figuring out what it is. You have to answer, as they probably taught you in a Software Engineering 101, if you happen to find yourself in a class like that at some point, you got to ask, what does the code do? What is the code supposed to be doing? What will be the consequences if I just leave it be? And if I'm going to change it, how will I know when I've changed it enough? How will I know when the problem is solved? And so once you've pinned down that difference between what you think is happening and what you think should be happening, you then need to track down its source. So sometimes that disparity can come from you misunderstanding one or the other. Maybe you misread a document, maybe you misunderstood someone's explanation, and you're defining it in a way that means there's obviously going to be a bug, like you're asking it to do something it can't. Or maybe there's a problem that's intrinsic to a system, not to your assumptions about it, and it's just the system's architecture or the problem it's trying to solve is just not the problem that you have anymore. Maybe lower level, you've got a tools problem, one of your dependencies is doing the wrong thing. You're going to have to go upstream and fix that in order to bring what it does into line with what you want. Maybe it's the business logic. This is where everyone tends to assume that a bug is coming from, but there are many other options. Because you can have your logic right and a tools problem and get a bug. You can have your logic right and just have the wrong architecture and get bad behaviors. And you can have your logic right and you can be getting an unintended side effect just based on some bug or flaw in your program or the ecosystem. And that could be introducing an unexpected behavior. So once you have pinned down exactly where the problem is that you're trying to solve and where that problem is coming from, start thinking about who will fixing it affect. It'll affect you because you're going to spend a bunch of time on this. It'll affect the other coders because they'll have to learn what you changed. It'll affect whoever writes the docs, whoever advertises your product, and whoever uses the product. So in the theme of history repeating, it's super important to talk about what you're planning to do in order that people who've seen others attempt similar things and fail for various reasons can volunteer you that information and keep you from making the same mistakes. So ask people about the solution that you're trying to do. Research what others on your particular project have done, and research what others on other projects have done and how it's worked, what's worked well, what's worked poorly. And see whether you can get buy-in from that project. When you say, hey, I would like to make this major refactor, I would like to rewrite this section of the code in that language. If people just reflexively go, oh, no, don't do that, ask why. Or if people go, oh yeah, I don't even know what you're proposing, but that sounds great, ask why. And one thing that stood out time and time again when I've talked with people about the refactors that they've succeeded at compared to the ones that they've failed at has been that the rewrites and refactors that prefer small changes are the most successful. So that can mean, if you're doing a very big change, to break the big change up into small, incremental, measurable ones. A small change, you could define it as the cheapest or quickest solution to get the impact that you need. It's the least effort that you can put in and still get what you wanted, which if what you want is a major speed up, let's say, then that could be a whole lot of effort, but still don't do more than you have to. And introducing extra complexity just for the fun of it or just for the fun of using some cool tool will cause you a lot of grief on down the line as you have to live with that. So basically, risks multiply. If you, it was described as innovation tokens in the previous Rewriting in Rust talk today, where you have a certain amount of risk you can take. If you take more than that, if you take a bunch of gambles at once, and any one of them failing will keep your project from succeeding, then the more gambles you add on, the less likely you are to succeed. So since risks compound, make the smallest change with the least risk that you can for the best odds of success. And I would like to stand on a small soapbox here to talk about what happens when somebody comes into some other project, some other community that they might not be super involved with, and just says, I think you should rewrite your code. I think you should go rewrite that in Rust. I think you should rewrite that in Go, whatever it might be. What is this actually saying? It's saying, I think all those hours you've put in, I think you should just throw them out. They were garbage. It's saying, well, I think that the work that you've been doing would be super easy to replace. It can't be that hard, right? Why do you even spend so much time on it? It's saying, you don't understand the engineering decisions that you're making because I know them so much better than you. And fundamentally, to somebody knowledgeable, you're saying something about yourself. You're saying, I have no idea what you're trying to solve. I'm wandering in and saying this one tool will fix everything. So please don't do that. Rust kind of has a problem with this kind of people. I'm not sure, I hope none of them are in the room or watching. If you have done that in the past and you're hearing this, please think about what it's saying both about you and the language and consider not doing it in the future. So what should you do instead if you're like, wow, these people need a different tool? Take it, look at things from their perspective. Start by figuring out where their problems are and how you're going to bring them more good stuff than the inconvenience that you'd be introducing by suggesting a change. Look at where their actual pain points are. Respect the amount of time that people have put into their project and the amount of understanding the complicated problem that their code is trying to solve that is encoded by every bug fix that makes their code look a bit messy. And ask whether they would be interested in a solution if you offered it to them. Ask what they've done before, whether it's succeeded, and what you can learn from that. And basically, try not to write code that a project just doesn't want, because that's a huge waste of time unless you're writing it for your own enjoyment. So let's talk in a bit more detail about rewriting for the sake of understanding the code. because I feel like in my upbringing as an engineer, it wasn't explained to me nearly as well as I would have liked that you don't always have to push the code you've rewritten to get benefits from having rewritten it. So a couple of I'm going to show you a couple of case studies, but from them, I'd like you to see what these people are doing right. They're picking either a familiar task or a familiar tool. They're not introducing a bunch of new risks, like both an unfamiliar task and an unfamiliar tool at once, and it sets them up for success to change a small thing at a time. They've documented what they've learned, which is what makes them so good for citing in a talk, and makes it easier for them to look back on their own experiences and continue leveraging the knowledge that they gained. And they really take the lessons that they learned back into their other projects. So one instance of rewriting in order to understand the code base is Carol Nichols is a pretty expert Rust programmer, and she encountered this compression algorithm that she thought, wow, that's kind of slow. I wonder if Rust could make it faster. So she assessed it, took it away, on her own just wrote a Rust implementation by studying the C code, and then has offered that as something that people can choose to use. Doesn't try to force anyone else to use it, but basically picked the smallest component, which in her case was the library for compression, and then just rewrote that, learning from the knowledge that was encoded in the old version. Another instance of rewriting to understand code is a project that Bart gave a talk about at the Portland Rust meetup, which was Advent of Code. And he had some familiar problems that were algorithmically pretty straightforward to him, but wanted to practice his Rust, and so he resolved the problems in Rust and published them, and that's fine. He's not going to anyone and telling them, hey, you should ship these Rust solutions. He's just rewriting to understand and can take that knowledge about how to handle memory and how to handle safety that he learned from Rust back to his other projects. So with that out of the way, a lot of the time when you talk about a rewrite, you are talking about the problem where production code isn't where you want it and you need new production code for some reason. So the first thing to ask is always, can we solve the problem in the current language? The perks of your current language, you already know it. You don't need to drag in a lot of new dependencies and new tooling. And you can potentially go off, rewrite for understanding in a language whose strengths match up with your present language's weaknesses, and bring that understanding back to write the algorithm in the way that you've learned is good, without dragging in a bunch of new tools to your build process. And a huge perk is that the existing code describes a lot of bugs that have been fixed over the years. It pretty much encodes your project's knowledge about the problem. So the better you can leverage that, the fewer reintroductions of bugs that you'll have. So there are times when you think, no, we've just got to toss it and rewrite it, when you could actually refactor it in your current language and be fine. Here's a few common excuses, like, oh, but it's slow. My language is slow and I want my code to go fast. Can you find and refactor the hot code so that it doesn't trip on those problematic edge cases of your current language and tooling? And can you find a faster implementation of your current language or your current runtime or whatever bit is slowing it down? If your current code is confusing, then writing a similar thing with similar processes in a different language is just going to end up confusing again unless you figure out how it got that way and fix it. So learning how to document better, pruning out dead code, simplifying and refactoring are essential first steps when your code is confusing. And then if you think you're going to have to change languages eventually, you can start by documenting that boundary where you're going to interface with the new language. And often by singling out the problem pieces of code that you wish were in a different language and documenting extremely clearly everything around them, you can reduce a lot of the ambiguity that was causing you problems to begin with. And another unfortunately common reason that some projects will consider just rewriting in some other language is that people are bored of the existing one. If you have a group of people who are going to get bored with one language, what's to say they're not going to get bored with the next one? So a rewrite is not going to solve your problems there. Some ways that can sometimes make people get less bored are give more recognition and kudos for the contributions that people are making. Communicate better about the costs of making changes you don't need. Have people speculate or research what those costs would be, and potentially make it more fun to fix the things that you wish they'd be spending time on instead through whatever means that might take. So sometimes, though, a refactor won't suffice. Sometimes you have just hit the wall on what your tooling can do, or you're looking forward and you're seeing, well, I can get up to this local maximum, but that's the best we're going to be able to do, and I need a long-term plan to set me up to get even further than that with potentially different tooling. So can Rust solve your problem? Who here knows a little bit about Rust by a show of hands? So about half the room. Who here has worked on Rust code in some capacity? So about maybe 10 or 20 people. So I will go through what Rust is and when you'd want to use it for both the benefit of those who haven't had the chance to work with it yet and anybody on the stream and the future recording who will be a little bit curious. So Rust's goals include memory safety. Basically, in any language that lets you manage memory, there's a bunch of rules that the program is that you're supposed to follow as a programmer in order to avoid making mistakes. And with Rust, you have the option of having the computer check that you followed those rules instead of just hoping you did it right. Rust shoots to be as performant as C, and we do this with what's called zero-cost abstraction, which means basically you can get the same code to run on the machine regardless of if you write it in the way that makes the most sense to a machine or in the way that makes more sense to a person. So the higher level abstractions won't slow your code down. And it has a minimal runtime. It has no interpreter, no virtual machine that you rely on, no garbage collection or any of that. You get similar guarantees to what you would from garbage collection about memory use, but those are calculated at compile time instead of at runtime. So you trade a slightly slower compile in Rust, where you might have a faster compile, but the occasional garbage collection hiccup in a GC language. And Rust prioritizes making it easy to integrate with other languages through the tooling that those languages already have, meant for integrating with C and C++, which have traditionally been the systems languages to connect with when you need finer-grained control than a higher level language is giving you. So when you get started with Rust, you'll hear things that sound kind of contradictory. They'll be like, oh yeah, you have guaranteed memory safety, except sometimes you don't, and this kind of thing. And that's because Rust covers a lot of space by offering you a lot of different choices. The first choice you'll get is, do you want stable Rust or nightly Rust? The stable Rust is always backwards compatible with the other stable Rusts, and so it moves more slowly. It's not exactly a long-term support, which if you need a language that will remain identical for 5 or 10 years at a time for your application, Rust is probably not going to be the best choice for you yet, unless you don't mind being on a pretty old stable. Nightly Rust, on the other hand, is all of the bleeding edge features that we're trying out. We're not sure if these are going to work. We're not sure if the nightly is going to work, but YOLO, let's go try things. So all stable code should run on nightly. If it doesn't, if it's a nightly bug, but there's a lot of features in nightly that won't necessarily run on stable. Basically, write in stable Rust for as long as you can, but you may find a dependency that requires you to use nightly. And it's very easy to use both of them at the same time on your computer with some tooling I'll tell you about in a minute. Rust will give you the option of safe or unsafe code. Most Rust code is safe, as in we check all of the memory usage to prove that there's no errors being made, that you're not, let's say, letting 2 different parts of the code read the same memory when they shouldn't, that kind of thing. Whereas unsafe says, this is a circumstance that we can't prove that, I'll prove it myself instead. So if you see Rust code with some unsafe blocks, that unsafe is a hint that you should stare harder at that to make sure it doesn't have, it's not doing anything you wouldn't want it to. When you're starting to make your own crate, when you're starting a new project, you'll have the choice of making a library or a binary. If you're going to be integrating your Rust code with some other language, you probably want to make a library because it can just be called into through that language's FFI, which I'll talk about in a minute. So you also have a choice between dynamic and static linking for the code that you produce, which dynamic linking says, so with either you're depending on some libraries that other people have written. With dynamic linking, you say, I'll just point at the libraries elsewhere on my system. And with static linking, you say, please bring in a copy of the bits of the library I need to my program. So dynamic linking will give you a smaller program that's a bit less portable across machines and across systems. Static linking will give you a bigger program that's a lot more portable. And Rust also gives you the option to cross-compile to quite a few different target platforms. So if, oops, we added a new platform and our current language just can't target it, but Rust can, is your problem statement, then a rewrite in Rust might be a great idea. So Rust will also offer you a really good tooling ecosystem, or a tooling ecosystem whose quality really surprises people coming from a systems programming background and feels very familiar to people coming from an application programming background with, where the languages tend to have a higher priority on user experience. So when you're first getting Rust, currently you'll get Rust through and choose which version of Rust you want to use at any point in time through a tool called RustUp. Bear in mind, if you're listening to this later on, that RustUp is nearer to the end than the beginning of its life cycle at this point, so it's worth doing a quick search to see whether the features have been integrated into Cargo. Which brings us to Cargo, Rust's package manager. And by package manager, I mean it's the thing that builds your project, makes sure you have all your dependencies, builds all your dependencies if you need it to, and will let you publish your project to a public registry if you'd like to share it with others. Cargo can handle multiple versions of various dependencies when you want it to as well. And then in terms of actually writing your code, you've got Rust format, which basically codifies a lot of recommended style guidelines for Rust code and will rewrite your code to conform to those style guidelines if you want it to. And we have the linter, Clippy, who, just like the Microsoft paperclip, will make all kinds of helpful suggestions, except Clippies are actually usually pretty helpful to make your Rust look good. So if you're writing some Rust, you're a little bit worried about sharing it with more expert people, you're like, oh no, I wonder if it looks bad, run it through Rust format and Clippy, and they'll tell you how it looks and help you fix it before anyone has to look. So if you're learning Rust, check out the docs, doc.rustline.org. There's more resources on community.rs/resources. And tomorrow, go to Nick's talk on Rust programming techniques. Hi, Nick. So with that, that's the super high-level view of what Rust is, and I'd like to dive into some places in the industry that have rewritten pieces of their code in Rust and what they've learned from it. And I'm going to show you two case studies, and they have a lot in common. First, they isolated a very specific problem that they wanted to solve, and they avoided rewriting code that they didn't have to basically minimize risk. They identified that problem based on the risk that it was posing them, essentially, and they made sure that at the end of the rewrite they would be exposed to less risk. The first thing they did was establish a workflow for having Rust as part of the project, for testing the Rust code as well as the other code, and for shipping that Rust code that went with the other code that they were working on. So that workflow has to come first, because without it, you can't really iterate on Rust code that does complex things. And remember, the goal is to make the small changes one at a time to get where you want to be. They had a small expert team of people doing the Rust part at first, because the communication overhead when you're iterating and trying new things and trying to explain, well, we tried that and it didn't quite work, so we modified it to try that, to a particularly large group can really slow you down. And they performed their rewrites incrementally. They made the first small changes to make sure they could ship Rust, and then a slightly larger change to make sure that all worked and see how Rust really performs in the wild. And then once they have that pipeline for adding Rust to pain points in their code, they can proceed to add it wherever they think that it's the right solution with pretty little additional overhead. So, and they do educate the larger teams working on the product about the Rust work that they've done, but they put that off until the Rust is succeeding. They don't try to keep them up to date or with every little detail unless they want to opt in and watch, because again, that communication overhead can be huge. So the first case study I'd like to look at is NPM, the Node Package Manager. So you can see there's several talks that I'll link because I only have about 45 minutes here, and I'd like to give you guys some time for stories at the end. Their first Rust service was a load balancer that would let them send some requests to a Rust microservice and others to the existing microservice. You can watch Ashley's talk there at that YouTube link of how they, once they had that load balancer in place and they could send some of their requests off to the Rust, they then rewrote some of their performance bottleneck code as a Rust microservice. And so they wrote their proxy, which is figuring out how to get Rust into their ecosystem. They ran the Rust in parallel, more or less, as I understand it, with their existing microservice for that for a while to make sure it was okay, and then they switched over to the Rust one, which really mirrors what Mozilla did, shipping Rust in Firefox through Project Quantum. There's several excellent blog posts about the scope, which is a huge scope of engineering work that went into this. But I like the summary that Lynn Clark gave of it. They were rebuilding a jet engine while the plane is flying because the top priority was don't break Firefox. Don't break Firefox for the users. So that's the huge difference, I think, between rewriting anything versus just building something new. And that's why a lot of the companies who've adopted Rust have chosen to start new on something instead of rewriting something existing. You can check out the Friends page, and if you look at the way that the various companies use Rust, relatively few of them are rewriting existing code compared to building the new things as they need them. Dropbox, Habitat, and Coursera are instances of companies that are building afresh instead, because the rewriting requires a huge amount of backwards compatibility. So, to talk a bit more about Quantum, though, they first had to figure out how the heck are we going to ship any Rust code in the Firefox build process. And that question was answered by attempting to ship a tiny URL parser in Rust to run alongside the C++ one, just behind a feature flag turned off. The users will never see that there's any Rust code in their browser. But we can test our build system changes to make sure that it will build. And then, once they'd made that tiny first change to verify that they could ship Rust, they proceeded to port components of an experimental browser engine, Servo, that's written in Rust, to their analogous portions of the Gecko engine, and basically wire it all together. So they made small changes a little at a time, and only once they were really succeeding did they bring in the rest of the engineering team and say, okay, now you need to start learning some Rust if you'd like to hack on these components. Now we'd really encourage you to start learning Rust, as opposed to trying to work together on it the whole time. So what's the techniques for rewriting your Rust code? Basically, if you're rewriting, you're not throwing the whole thing out and starting over, which I would sincerely recommend not to do in almost all cases. You're rewriting a function or a microservice. You probably are going to need to use foreign function interface, which is a tool that's been around for just about as long as C has for calling some language, which we call the guest. In your case, that would probably be Rust, from the language we call the host. That's the language that your project's written in. And there's a bunch of examples of FFI from Rust out there, and it's also, you can check the first edition and second edition of the Rust book for more on this. So I'm going to show you a super tiny example of FFI to do some math from Perl to Rust. There's going to be 4 files. The cargo.toml configures how the Rust gets built and what metadata the Rust has. Main.rs contains your Rust code. Main.pl contains your Perl code that will call the Rust's function. And the Makefile builds the Perl code and runs cargo to compile the Rust. So your cargo.toml, you say what your package is, and you give it a library name. This is going to be a dynamically linked library because we don't really care about portability across platforms for a small example. You're going to have a main function. You need the no-mangle directive here because you need to make sure your function has the same name as it has here to make sure that it can be called from your other code. And you're just going to take an integer and return twice that integer. So in your Perl code, you will use Perl's FFI mechanism, which there will be something similar in pretty much any language, to bring in that function and make it available to your code. And then you will call that FFI function with your input. And when you call that function with your input, it will run the Rust function that you called in. The Rust function will double it. And then you can do whatever you want with it, in this case, output it. So it's really not as much boilerplate as you might be afraid of to just call a little bit of Rust when you want to. The Makefile works on Apple and Linux and will just run cargo build to create the Rust and then run the Perl when you need to. So that's FFI in a tiny nutshell. And the other thing you might need if you're building portable code is static linking. And to statically link Rust, you can check the docs. You can make a crate of the type static lib, and you can use the muscle library in lieu of libc, because muscle is designed for static linking, so it's easier for the compiler to stick whatever function it was you needed into your code that you're emitting. And you may need, if you have a bunch of dependencies, to also recompile them with muscle, because your dependencies will be included when you compile as well. So if you can FFI from your host language to your target language, and if you can statically link that Rust that you're FFIing into so it doesn't drag any extra dependencies along, you've pretty much got it made for basic rewriting sections of your code in Rust. However, a bunch of other people have done partial rewrites and have produced tools that you might find fun and interesting if you're using these languages. If you're working with Ruby, check out Helix, which lets you write Ruby in your Rust, Rust in your Ruby, and various combinations thereof. If you're working with Node.js, check out Neon. And if you are Mozilla and you need to procedurally generate a lot of C bindings to work with Rust code, BindGen exists. So that's rewriting in Rust in a very small 45-minute nutshell. If you have questions about rewriting in Rust, first about rewriting parts of your code, rewriting in Rust, check with your project and your mentors first, because it's often as much a cultural decision as a technical one whether you're going to rewrite. Check in your host language's documentation for how you can integrate with other languages. And when you get to your Rust questions, ask on IRC or ask on the Rust users forum, or contact the particular Rust team that you have a very high-level question for directly if you need to. If you'd like to talk to me, if you'd like to ask me questions personally, I'd recommend lca@edunham.net. And I would like to take the last 5 minutes to be a little unusual for this conference. I'm not going to encourage questions, though if you have something you'd like for the recording, you may ask, but I would like to hear your short stories of rewrites and of rewriting code or the impact that others' rewrites have had on you, or fun that you've had with Rust, just as a bit of a chance to share. So it looks like we've got about 5 more minutes till the cutoff time, so would anyone like to share anything?
First of all, thank you. Stories. Don't be shy.
Wow, it must be the after lunch slot. We've got one up here and one over there.
I didn't rewrite it in another language, but I just, there was some code for implementing a sort of LDAP authentication for people, but it used non-standard schemas and non-standard lots of things, and a very old version of LDAP. So I rewrote it as middleware and using standard open LDAP, well, standard schemas like group of names instead of some made up attribute, so that it could work to support other, would fit into things like Jenkins and other systems that expected particular schemas. And, well, it worked. It was successful, but it took more effort than I expected.
Yeah.
Still being used now, years later.
Sounds like that might have made it a lot easier to test, but might have introduced a lot of new bugs. We've got a story or a question over there as well.
Oh,
go ahead. Sorry.
So I'm rewriting an embroidery library in Rust, and there are a couple of projects that you didn't, that probably slipped under the radar. One of them is Corrode, which basically looks at the C syntax tree and converts it into Rust. And the other one, whose names escape me, but basically is able to generate C headers for Rust code. And I found that really useful when trying to use some Rust code and some C code together.
Absolutely, yes. Corrode is less actively maintained than it was when it was under active development, as I understand. But if you have a big chunk of C that you would like automatically translated into unsafe Rust, Corrode is your friend.
So that's almost mine. I've got 3 large chunks of C code. Where can I find somebody who wants to rewrite it in Rust?
That is a fantastic question. There are a few things you could do. If the code is public, I would recommend searching for people who are being sort of rewrite trolls on GitHub who say, you should go rewrite that thing, and then hop into their issues and say, if this project doesn't want you to rewrite it, I would love to have your help. If you want to troll the trolls back. In a less snarky answer, I would say find your local Rust meetup, post on the Rust users forum. Frankly, attempt to do it however poorly, and show your attempt at the work far and wide, because often a poorly done thing will goad people into offering fix-ups in a way that a request for advice just doesn't. So some of my greatest success with writing things in languages I'm not familiar with has been from writing it very poorly and showing it to people who are experts in the language and saying, I tried, pull requests welcome, and they'll go, oh, that hurts my eyes here. So those are my suggestions for you. You might also find someone in the room afterwards as well. So any other stories or questions? Looks like we've got about 1 minute left. One back there.
I have a very large Perl script of about 17,000 lines, and I had someone come to me and say, hey, I wouldn't mind making these changes so it would work with our system, and I said, well, I'm not going to do it because it's not what I support. And they came back and they said, well, here you go, and actually it improves performance by something that took 30 seconds to run now takes 5 seconds to run. So you just let people do things and it helps and everyone benefits.
That is absolutely the perk of public code. So with that, I'd like to wrap it up and say thank you all very much for being here. I would strongly recommend attending Nick's talk tomorrow. If you'd, it's a tutorial session if you'd like to learn some more Rust. And we have a little conference thing.
And we have the speaker guest. Thank you very much, Emily. I can tell that by your clarity and your diligence that you must be an excellent engineer, and if you ever want to come to work on the projects that I'm organizing.
We were joking last section that we're both Mozillians, but in totally different branches of the organization. Yeah. So yeah, thank you very much, and thank you LCA for having me once again.